We're going to take another look at multiplying decimals. So I know that you guys did this last year and probably a little bit the year before that, so we're not going to spend a lot of time on it today. We're just going to take a quick look, kind of a review. Now, this is one thing that you may not have talked about much last year, but I know we talked about it earlier this year. When we're multiplying, okay, we talked about it with fractions and we talked about it with integers. It's the same rules for decimals. If we're multiplying, how do we know whether our answer is positive or negative? Bella? Very good. Okay, it has to do if the signs are the same or if the signs are different. Okay, what happens if they're the same, Bella? And if they're different? Okay, now you specified greater than 0, less than 0. What does greater than 0 mean? Positive. And less than 0 is? Very good. Okay, so if the signs are the same, the product is positive. If the signs are different, the product is going to be negative. Okay, now that's true for fractions, decimals, integers, variables, everything. Okay, that's always going to be the case for multiplying two terms together. Okay? All right, now let's talk about our step-by-step process for multiplying decimals. Okay, this stuff up here is kind of set off from everything else. Okay, this is kind of like our guidelines for what we're going to do. Okay? So, to multiply decimals, just like when we were multiplying integers, okay, we said that we stacked the numbers. Okay, and I think it was Alana said that when we stack those numbers, she said line up the ones place. But if we're talking about decimals, it's not necessarily the ones place. What we are going to line up is the rightmost digit. Okay, whatever digit is farthest to the right. They won't necessarily be the same place value. They might be ones and tens, they might be tenths and ones, but we want to line up the rightmost digit. Okay, once we have those lined up, we're going to multiply. And we're going to multiply normally, just like you learned to in probably third grade. But what's really, really important about that multiplication? Okay, for instance, on the starter, we multiplied this 3 through by all those digits. What did we have to do before we could multiply that 2 by everything? Cammie? Good. Okay, we need to remember our place-holding zeros. Okay, we cannot forget those. They're super important. I think a couple of you might have seen on the starters what happens if you forget them. Okay, it throws your whole work off. Okay, so make sure that you're putting those place-holding zeros. Okay, then what did we do? Okay, so we multiplied the 3 by everything. We had the place-holding 0. We multiplied the 2 by everything. What came next, Mark? We added those products. Now, when we add those products, okay, make sure that we are regrouping as we need to. Okay, you may not need to regroup at all. You may need to regroup a bunch of times. But regroup wherever you need to. Okay, then lastly, this isn't a big concern when you're talking about integers, but when you're multiplying decimal factors, a lot of times you're going to have a decimal product. The question becomes where to put that decimal. Does anyone remember from last year how you know where to put that decimal? Oh, good, a few of you. Kathy? Perfect. Okay, I'm going to change your words just a little bit, okay, just because I have short space up here. But the number of decimal places in the product, in the factors, okay, and those two numbers that we're multiplying together, however many decimal spaces we have in those factors, is going to be the exact same number of decimal places that we have in the product. And for whatever reason, it's decided that it wanted to look different. So we'll fix that. There we go, all better. The number of decimal places in the factors, so we add them all together, count them all up. That's how many decimal places we want to have in the product. Okay? The pro cut, what's a pro cut? Much better. Thanks, Cammie. All right. Now, let's take a look at some examples, and let's talk about these steps as we go through them. So first off, I want to multiply these two numbers together. Before I look at the numbers themselves, I want to look at the signs. And I notice that one's positive, one's negative. They have different signs. And if the signs are different, Bella told us our product is going to be negative. So after we go through and get the numerical part of our answer, we'll know that our answer has to be negative. Okay, now, let's set this up. And we'll put 0.06 up top, and we'll multiply it by 4.7. Now notice I've got the 6 and 7 lined up. Even though the 6 is in the 100th place, and the 7 is in the 10th place, they're the rightmost digits. So we line those digits up. We don't add any extra zeros for multiplication. Okay, not in the original factors. Okay, so then I do 7 times 6 and I get 42. So I write the 2, I'll put the 4 up here. Then I'll do 7 times 0, which is 0. Plus 4 gives me 4. And 7 times 0 gives me 0. Now, before I can multiply this 4 through, okay, I stack the numbers, I line up the rightmost digits. When I multiply normally, I need to remember those place-holding zeros. Okay, so I need to put a 0 underneath that too. And now I can multiply this 4 through. Okay, so 4 times 6 gives me 24. I write the 4, bring the 2 up top. 4 times 0 is 0, plus 2 gives me 2. And 4 times 0 is 0 again. Okay, now I can add these columns. I multiply normally. I remember those place-holding zeros. Now time to add those products. Okay, so 2 and 0 is 2. 4 and 4 is 8. 0 and 2 is another 2. 0 and nothing, and I bring down 0. So finally, the last piece that I need to do is I need to know how many decimal points to use. Okay, so I look at my original factors, and there are 3 decimal places in my factors, which means I need 3 decimal places, 1, 2, 3, in my product. So our final product here is going to be 0.282. Keep in mind, we said way up here, if the signs are different, which they are, our product is negative. So our final product is negative 0.282. Okay? All right, let's look at the second one. Okay, let's start by stacking those numbers, lining up the rightmost digits. So I'll put 2.43 up top, and I'll put 4.3 right here. Now, before I actually do the multiplication, before I actually get to that part, I want to look at those two factors. And what do you notice about those two factors? Justin? They have the same sign. Okay, before I actually consider the numbers, I look at the signs, and those signs are the same. So what does the fact that the signs are the same tell me about my product? Karime? It's going to be positive. Very good. All right, so now I can get back to the numbers. Okay, and I've got them stacked, with the rightmost digits lined up. Now it's time to multiply normally. Okay, so we'll just go through and we'll do the multiplication. So Braden, help me out here. 3 times 3? 3 times 4? So I'll write the 2 and I'll put the 1 up here. 3 times 2, and then one more? Great. Now, before I can multiply the next line, what do I have to do, Kyle? I need that place holding 0. Okay, don't forget that place holding 0. Okay, now we can multiply that 4 through. Go ahead, Kyle. Plus one more? Good. Don't forget that extra 1. Okay, and then 4 times 2? Very good. All right, now we'll add those two products together. Go ahead, Katie.
9 compared with 9. 2 is 4. 7, 14. 9 plus 1 is 10.
Very good. Now, the decimal places. How many decimal places do we have in these factors? How many decimal places in those factors? We haven't heard much from yet. Yes, Hannah.
3.
3 decimal places. Very good. Which means I need 3 decimal places in my product. 1, 2, 3. And I have 10.449. Now, should it be positive or negative? Well, what did we say at the beginning, Sergio? Very good. We said they have the same sign, so our product is going to be positive. All right, what questions do you have on either of those two? I know we only looked at 2 of them, but what questions do you have about them? Nothing? Go ahead. All right, let's take a time out here. All right, the question that we had, guys, had to do with the lattice method. Now, this is going to work a little bit differently than the lattice method for multiplication. If that's the only one that you've ever used for multiplying multiple digit numbers, okay, then we're going to need to learn how to do the old multiplication method in order to use this, okay? So if you need help on that, feel free to see me outside of class. Right now, we're going to assume that you have that part, and we're going to go from there, okay? Yeah. Yeah. In fact, right now, Shane, can you come up here, please, and write these, or tell me this first. Before we look at the numbers, what do we see about these two factors we're going to multiply together?
The signs are the same.
The signs are the same. So what does that tell us about the product? It's going to be positive. Okay. Now, Shane, can you come up here and write these numbers, stack them as if you were going to multiply? You don't have to actually multiply. Just get them set to multiply. Let me bring that down a little bit for you. Hang on. There you go. Might be a little easier for you. All right, so Shane's got a couple things a little bit mixed up here, but that's okay. We'll fix them. First of all, Shane, once we talk about the signs, we can kind of ignore them for a couple minutes. Okay? We'll come back to it. So you can write them here if you want to, but you don't have to. Okay? Now, what should we do? What typically do we do to make our jobs a little bit easier to start with here? Good, okay? We're going to flip these two numbers. Now, Shane, we can have them in whatever order we want. That's what's really cool about multiplication. It's commutative. So you can multiply 2.6 times 12.51, or you can do 12.51 times 2.6. Typically, it makes our jobs a little bit easier if the number with more digits is up top. Okay, so it's going to look like this. Okay? Good. Now the last thing that we want to be really, really careful about, the digit that's furthest to the right, that has to be lined up in both of our factors. That's what gets lined up, whatever's farthest to the right. Okay? All right. Let's see. Talia, can I get you to come up here and multiply this 6 through for me, please? Just the 6. I got this if you need it. Very good. Thank you very much. Okay, let's see. Justin, can you come up here and do the whole next line for us, please? Okay, so Talia multiplied through. She did 6 times 1 was 6. 6 times 5 was 30, so she wrote the 0, carried the 3. 6 times 2 is 12, and 3 more is 15. Put the 1 over the 1. 6 times 1 is 6, plus 1 more is 7. Justin, right away, remembered that we need that placeholding 0. Okay, then he did 2 times 1 is 2. 2 times 5 is 10. Carries that 1. 2 times 2 is 4, and 1 more is 5. Very good. Tell you what, Justin, why don't you finish it off for us? Excellent. Okay, so we did the multiplication part. Now we need to think decimals. So Kayla, tell me this. How many decimal places in our factors? 3 decimal places in the factors. Okay, so that means how many decimal places in our product? 3. 1, 2, 3. So we have 32.526. Okay, should be positive or negative? Very good. We said that it's positive. That's not changing. Okay? All right. Now what I'm going to do, I'm going to give you guys about a minute and a half to multiply this one out. Okay, so do number 4. Give you guys about a minute and a half to do that. Go. Okay, while you're working on those numbers, tell me this. What do we recognize about the signs? They're different. What does that mean about our product?
It's going to be less than 0.
Very good. It's going to end up being negative.
Then I'm going to take it.
All right. Go ahead, Katie. Got it mostly set up for you. You just got to fill in some blanks. Nothing wrong yet. Okay, now there's one last piece. Very good. Okay? So the multiplication, we can see that. We can see what you did there. Now, right here, okay, we have 3 decimal places in our factors, which means we need 1, 2, 3 decimal places in our product. So, Katie finished it off with negative 6.177. Okay, one of our factors had different signs, which meant that their product was going to be negative. Okay? Now, I want to point something out. All 4 of the examples that we've done have had 3 decimal places in their product. That is just a coincidence. Okay, we can't count on that happening every single time. Okay, in fact, we can have any number of decimal places at any given time. It depends on the decimal places in our factors. So don't think that it's always going to be 3 just because these ones were. It won't always be 3. Okay? All right, guys, what questions do we have about any of those 4? Nothing? We're all 100% okay. All right, well, when we multiply, whether we're multiplying decimals or integers, we're going to start off the same way. We stack the numbers, and we line up the rightmost digit. It doesn't have to be place values lined up. It's whatever digit is farthest to the right. Typically, we put more digits up top and fewer digits on the bottom, but you can do it in whichever order you want. Okay, but then we multiply normally, just like we always did, okay, except the lattice method. We use the regular old stack method. Okay, we multiply the one digit through, or excuse me, the rightmost digit through everything up top. Remember our place holding zeros, and then multiply the next digit. We repeat if we need to. We'll add those products together, regrouping where we need it. Just remember that the number of decimal places in our factors is equal to the number of decimal places in our final product. Yeah, Jake? Excellent question. Why do we have place holding zeros? So let's take away the decimals for just a second. And let's multiply 321 by 18. Okay, so I multiply 8 by everything. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, plus 1 more is 25. Now, I want to multiply through by 1, but that's not a 1, is it? What is that? 10. So because I'm multiplying by 10 and not by 1, I need to represent that I'm not multiplying by 1. I'm actually multiplying by a tens place. So that's why we need that 0 there to move everything else over. Understand now? Okay, so then I'd multiply 1 and 1 is 1, 1 times 2 is 2, 1 times 3 is 3. I'd add it, and there we go. Now it's the same idea with decimals, except it's not necessarily going from the ones place to the tens place, but every time we shift over to the right, we're going up by 10%. Okay, we're going up by, or I should say by a power of 10, really. Okay?